Welcome to 5 Minute School. Today's video we'll be talking about the valves of the heart. I've included a diagram here which shows the heart in a good amount of detail, and there are quite a few labels on here as well. But in today's video we'll just be talking about the valves, which you can see on the left and right side of the heart. So the left side here and the right side here. And we also can see the semilunar valves here. Now, we know already that the heart consists of cardiac muscle, and if you didn't know, cardiac muscle is basically consisting of myocardial cells, and between these myocardial cells they are joined together by intercalated discs. But it's not just cardiac muscle which makes up the heart. We have a fibrous skeleton in place which helps to keep the structure of the heart. Now this fibrous skeleton is going to be consisting of connective tissue. So just to make things a bit more clear, the atria and the ventricles, they are separated into two functional units by a fibrous skeleton which is made up of connective tissue. And obviously we need to enable blood to pass through this fibrous skeleton, so there are valves or atrioventricular valves embedded within this fibrous skeleton, and this allows the passage of blood to go through. Okay, so the atrioventricular valve between the right atrium, remember this side is the right side, the right atrium and ventricle is known as the tricuspid valve, and this has three flaps. You can't see it so well in this image, but when the valve is actually shut, it is quite clear that there are three components to the valve. On the left side, between the left atrium and ventricle, we have the bicuspid valve, which is also known as the mitral valve, and this consists of two flaps. So, the atrioventricular valves allows blood to flow from the atria to the ventricles, but normally prevents the backflow of blood. And opening and closing of the valves occurs due to pressure differences between the atria and ventricles. Remember, when the atria is filling with blood, these valves are closed. If they were opened, then blood would just fill the atria and straight away fall into the ventricles. So when the atria is filling with blood, these valves are closed. When the pressure in the atria gets very high, then it forces these valves to open, and then blood passes through from the atria into the ventricles. And then when the pressure is building up in the ventricles, this pressure causes these valves to snap shut. Okay, and that's how blood can pass on the next cycle from the atria, because the valves were already shut from the previous closure from the ventricles. Okay, so what we need to bear in mind is extremely high pressures which are produced by the ventricles could invert the atrioventricular flaps. Now what we need to remember is we're just discussing the basic physiology of the heart. There are various cases where we have pathological processes going on, and for example, if we have excessive pressure in the ventricles because the heart is trying to compensate for lack of oxygen in different parts of the body, so the ventricle is pumping extremely high pressures of blood, then this pressure could be so high that it could force these flaps to push back open, to invert into the atrium. Okay, so this is a pathological disease. So extremely high pressures produced by the ventricles could invert the atrioventricular flaps, and this is prevented in some cases by contraction of papillary muscles within the ventricles, which are connected to the atrioventricular flaps by strong tendinous cords called chordae tendineae. Okay, you can see them from this image here. They're connected to the papillary muscles of the heart, and it's a fibrous cord which is attached onto the valves. And let's see it clearly. It's this cord here which is attached onto the valves to prevent them from inverting. And that's sort of a prevention. But remember, in some cases there could be damage to these cords as well. So we're just learning the physiology for now, but it is important to bear that in mind. Lastly, we're going to talk about the semilunar valves, and they are located at the origin of the pulmonary artery and aorta. They open during ventricular contraction, and when the pressure in the arteries is greater than the ventricles, they snap shut. Okay, so let's have a look at them here. You can see it from the right side of the heart. The ventricles are here. Here we have the pulmonary artery, and we have the semilunar valve here, which obviously prevents backflow of blood from the pulmonary artery back into the ventricles. So it's the exact same purpose as the atrioventricular valve. So the pressure in the ventricles is going to get very high and force these valves open, and then blood's going to go into the pulmonary arteries. But when the pressure here is higher than the pressure in the ventricles, these valves are going to snap shut. Okay, so that's everything I want to talk about in this video. Thank you very much for watching.